Hey everybody, in today's problem of the day, we are finishing up a section of questions here. We had question 37 and 38. We did 37 yesterday. This is a calculator portion of the SAT, and it is a gridded response. A botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. The population of this species that the botanist expects to grow next year, that's N sub next year, can be estimated from the number of plants this year, that's N sub this year, by the equation below. The constant K in the formula is the number of plants the environment is able to support. The botanist would like to increase the number of plants that the environment can support so that the population of the species will increase more rapidly. If the botanist's goal is that the number of plants will increase from 3,000 this year to 3,360 next year, how many plants must the modified environment support? So I'd like you to pause, try this problem, and then press play. So next year, we want to have 3,360 plants, which means N sub next year is 3,360. That equals N sub this year, which is 3,000, plus 0.2 times N sub this year, which is 3,000 again, times 1 minus N sub this year, 3,000, over the total number of plants the environment can support, which is K. So we want to solve for K. So we will subtract 3,000, so we're moving this 3,000 over. 3,360 minus 3,000 is 360, equals 0.2 times 3,000. Times 1 minus 3,000 over K. The next thing I'm going to do is divide both sides by 0.2 times 3,000. Now when I do that, I need parentheses around this entire denominator so that it divides correctly. So I have 360 divided by 0.2 times 3,000. And that is 0.6. So I get 0.6 equals 1 minus 3,000 over K. Okay, now I will subtract the 1. So 0.6 minus 1 is negative 0.4. So negative 0.4 equals negative 3,000 over K. Now, negative equals negative, that's the same as positive equals positive, so I'm just going to deal with positive numbers. Now, the fastest way to solve an equation like this is to treat it as a proportion, so this side over here is over 1, and in a proportion, I can always switch things diagonally, so I'm going to exchange these elements to get K equals 3,000 over 0.4. So we have 3,000 divided by 0.4, and that is 7,500. So the value of K, in order to have 3,360 plants next year, K is going to have to be 7,500. And this is a gridded response, so for my grid, I'll put in 7,500. And we have to be careful to make sure we actually put these bubbles in correctly. It does not matter what we write up here. What really matters is what goes in the bubbles.